Hello everyone, uh, my name is Joshua and welcome back to lesson 2 on the forces of mortality. And today I would love to take you through Makehams Law of Mortality. And the Makehams Law, before we start today's lesson, as usual, I always use and prefer latex. But if you don't know how to use latex, don't panic. The aim of our lesson is to gain the concept of deriving the Makehams Law of Mortality. So that is that. So before I start today's lesson, I would love to tell you that I can derive so many formulas, both in statistics, in calculus, and in actuarial units or actuarial field. So if you get any difficulty in deriving any formula, you can reach on to my the comment section. Let me know which formula you need and I will do that for you. So today's lesson, let's jump into our lesson today and begin with a question such as this. You can be asked a question that says that show that if Makehams Law holds for all ages that are greater than or equal to let me see. For all ages that are greater than or equal to alpha, for all ages that are greater than or equal to alpha, there are positive constants there are positive constants that is S and G such that we have the probability of a person age X, such that we have you can pause the video and read the question, so that we have the probability of a person currently age X surviving to the next t years, equaling to S raised to t multiplied by G raised to C to power X into CT minus 1. So let's move right ahead and start today's lesson. So the force of mortality mu x, the force of mortality mu x, the force of mortality mu x the force of mortality mu x in Makehams law is always given by a constant A, constant capital A, plus a constant B multiplied by C raised to x. Yeah. So this is the force of mortality, and we know that from the basic concepts, the probability of survival, from the basic concepts that the probability of survival is always equal to, it's always given by the exponent of the exponent of negative integral from 0 to t of the force of mortality, the mu of mu x plus t, mu x plus t. So this is what we know, and this is what we are supposed to know, that the force, the probability of survival, let me mean like this. The probability of survival of a person currently age X, the probability of a person currently age X surviving in the next 2 years is given by the exponent raised to negative integral from 0 to t of mu xt with respect to t integral from 0 to t of mu x plus t with respect to t. Why is it not bringing that? Okay, so this is where we start derive. So we want to come from here to this place. So our next step is to form this mu x into mu x plus t, is to form this part, this one. So we have this here. Let me just place it here. Bye. If now we have mu x as a plus bc raised to x, it implies that it implies that mu x plus t, mu x plus t, mu x plus t, it implies that mu x plus t will be equal to mu x plus t will be equal to this x plus t. This implies that if mu x is equal to this, then mu x plus t will be a plus b c raised to x plus t. So the next part from here, we want to substitute this mu x plus t, this one here, then integrate with respect to t. So let's do that. So let's substitute it. Okay. We want to substitute this mu x plus t with so that we have to integrate from 0 to t. This one we have to integrate from 0 to t a plus that. So let's extract this integral, this integral expression. Let's extract it so that we can integrate it separately before so when we integrate this part, let's integrate it step by step. When we integrate this part, we will have a is a constant. When we integrate a constant, we will have the power of t here. The power of t here is 0 because we're integrating with respect to t. The power of t here is 0. So when we're integrating this constant, we will add 1 to that power of t. So we will have here an a multiplied by t. That's the first one. We have integrated. We've now integrated this constant and gotten that. So we will have again, we move to the next one, plus. Let's add shift plus now the integral now we will we will be adding the integral of this. Now, remember that this we integrated quite easily in the other the converts law, and we got, when we integrate this and when we integrate this, we will get b is a constant and c raised to x is a constant, so we will have to integrate c raised to t, and when integrating this we will have these constants multiplying c raised to t over log c. Then we substitute. Let me just write what I'm saying at the moment. Let me write that. Okay, so we'll have b first, then c raised to x, then this, then this will be multiplying this will be multiplying c raised to t, actually it's a fraction, c raised to x, c raised to t, we get c raised to t all over log c. All over log c. So yeah, so we have something like that. Then we replace this one. Back here. We will have the integral so we'll have the integral to be equal to, we have this a t we have at plus now what we got down here. So let's copy the whole of that and place it right there. So that's what we have now. Then let's place our limit. Our limit is from 0 to t. Limit is from 0 to t. From 0 to t. So replacing our limits, let's start with this t. Remember, what we are doing at the moment, we're just dealing with this part here. We're dealing with this part. We've come from this part to this part, whereby we are dealing with this part whereby we extracted that part here, and then we have integrated this first place to this, then integrated that to get that, then we reassembled them to this. Then we now want to substitute our limit in the whole of this equation. So substituting our limits, we have t. So because we were integrating with respect to t, so where we have t, we will substitute t here. Where we have t here, we substitute this t. So you notice that this equation will just remain the way it is when we have when we will be substituting for t. Let's place it. The equation remains the same. So the equation remains the same. You have an equal sign somewhere there. Then we subtract. Let's have a bracket somewhere. Let's have a bracket somewhere so that we can I don't know if the bracket will close that quite well. I think it closes it quite well. So we have our first part as this. Then our second part now, we want to substitute 0 to this equation. So substituting 0 to this equation, substituting 0 here, where t is, we will have this one changing to 0, then this one changing to 1. So let's place them. So the first part, that a disappears, then we remain with the second part, whereby we will only have the c raised to t here. We'll only have the c raised to t here changing to 1, because anything raised to 0 is 1. So let's subtract that. Let's there. The one did not appear. It has to appear. Yeah, that way. Now we have it now at this point. We're subtracting this by that. So you notice that this one and this one, they have a common. So when we open these brackets, we'll have something like this. When you open the brackets, we will have something like this. Still the same. Then you notice that this one and this one are the same for this function, and this one, they have, this one here have the same, denominator, so we can collect them under one fraction and have them as follows. We'll have this one equaling to 80. Let's start with that. 80 plus, we are supposed to add, oops, don't seem small, don't be close, too close. That plus is too close. Let's try and separate it all. Just refused. So let's leave it that way. Okay. So we'll have bc raised to x multiplying into bracket. Let's place it under fraction. That one we will be having, that is, we'll be having c raised to t minus 1, we're subtracting 1, all over log c. So okay, that is that. Now we have something like this. Now now that we have something like this, if this one is now after integrating and substituting our limits from this place, now what we have to do is to take this, now to take this one back here. It's now to take this one back here. So let's take this probability of survival first. Let's bring it down here first so that we can deal with what we are seeing. Then let us now replace this part, only this part, leave alone the negative, only this part, by the whole of that. So let us replace it, leaving the negative of, to copy it from there. Take that place. Let's see what it brings. Yeah, true. Now we've now done it correctly. Let us place this negative is outside. We've not opened the bracket. The negative is outside. It's outside. Okay. Now we have this one here. Remember that we have an exponential here. So this exponential, we have this function of t, and this one also as a function of t and x. So we have these two functions, and if we have these two functions, they are under the same base, we can use the laws of indices to separate these two these two function of t's, these two functions of t to have something nice. Let's allow me separate it first for you so that you can see what I'm trying to bring on. So what I'm trying to do here is to separate this. Let's start with this one. Then I have another exponential here. Another exponential here. I think it should be running now. Now, let me remove this brackets, making it look ugly. Now, remember that this negative is aside. So when it opens the bracket, we will have it here and also have it here. Okay, so let us have it there. The negative should be there and again be here negative. So that negative there again. So this is what we have now. We've now separated these two. To have something like this. Remember, this one is a multiplication, not an addition. So we're supposed to have a multiplication sign here. Oops. Let's just leave that. So these two functions are multiplying themselves. So we are multiplying. There is a multiplication sign here. That is by this. So that this, by the laws of indices, for this to stand, there must be a multiplication between these two bases, so that we can add the powers to this. Now, our next thing now, we know how we solve this part in the video of Makehams Law. Okay, let me help you solve this part. This part, for us to have something like this, let me extract that and bring it closer. You see this? I want to bring it closer so that you can see it as we are. Let me bring it closer so that we can see. Let me bring it closer so that you can see what I want to do. Let me just place it right above here. I just want to place it to bring it down here. Let me bring it down here. Okay. Yeah. For visibility. Now, as you can see, I've just brought the upper our aim the aim of our lesson was to derive this up to this point. We've reached here. Okay, we've reached here, and we now want to extract this part. Here. First, we want to set it aside from this part. So what we do is to set it aside, and that one will be done when this one multiplies the numerator, then this denominator, we bring it back, we bring it below b here, this denominator, because this log function here divides the whole expression here. So let's bring it, let's solve that. We don't need that more anymore. Let's copy it first. Let's run it so that we can see first before we do anything. Okay, now let's separate it. How are we going to separate it? We can take this b, this negative b, is negative b here, then pick this one out of the log function, and pick this one and pick. Now what do we have here? Let's look at what we have now here. We have I brought this one here, then this one remained multiplying that one. This one remained multiplying the numerator. That's what I've done here on this one. So from now, when you reach this point, it's just substitution of what I'm going to show you. According to Makehams law, the exponential negative a is equivalent to s, meaning s is given by let me enter math mode first. Math mode. This s is equivalent to the exponent negative a the exponent negative a and that g and the g the g is always equivalent to, from the Combat's law, exponential negative b all over log c. So exponential negative b all over log c is here. Let's copy it. Yeah. I'm missing something somewhere. using this. Using that. Let's see. Okay. Just press OK there, so it can look beautiful a little bit. Okay, now we have this. So what is remaining is to substitute G here. G will replace this part, the whole of this part, and S will replace the whole of that part to give us what we have here. Yes, so when you substitute S here, you will have the T remaining to that, and when you substitute G there, you will have this remaining part here. So we are done with our today's objective. Don't forget to like, follow and subscribe. Again, don't forget, if you have anything that you need me to help you derive in statistics or in actuarial units, I'm here. Just reach out in the comment section and give me your request and I will deliver. Thank you for watching. See you soon.